Hello, everyone. My Capstone project focuses on developing a machine learning model to predict the net hourly electrical energy output of a combined cycle power plant based on hourly environmental sensor readings. This is a crucial task for power grid planning and efficiency optimization. First, the modeling approach. This task is to predict a continuous numerical value, the power output in megawatts, from a set of labeled inputs, making it a supervised learning regression problem. All four ambient features, temperature, pressure, and humidity and exhaust vacuum were used as predictors. For algorithms, I chose two, linear regression as a simple interpretable baseline, and the random forest regressor, a powerful ensemble method known for capturing complex nonlinear relationships in data. Finally, I chose root mean squared error, or RMSE, as my key evaluation metric. RMSE measures the average magnitude of the errors and is preferred here because in power plant operations, large errors are much worse than small ones. To build and optimize the model, I first implemented a rigorous data splitting strategy. I set aside 20% of the data as a dedicated test set for the final honest performance check. For model comparison, I used five-fold crossed. This is a better than a single validation set because it uses all training data for both learning and validation. I compared the two candidate models using the cross validation results. As shown in the table, the random forest regressor achieved a significantly lower average validation RMSE of 3.88 megawatts compared to the 4.52 megawatts of the linear regression baseline. The random forest model was further tuned by optimizing its hyperparameter, ensuring it was the best possible model before moving to the final step. Based on the validation results, the random forest regressor was selected as the final model as it provided the best trade-off between accuracy and complexity. This screenshot shows the final model in action. This is a plot of the predicted power output versus the actual power output for the unseen test set. The points cluster tightly around the diagonal line, visually confirming the model's strong predictive capability on the new data. The selected random forest model was then evaluated one time on the completely unseen test set to get an unbiased measure of its performance. The final evaluation yielded a test set RMSE of 3.86 megawatts. This is an outstanding result. It means that on average, our model's estimate for the power plant's output is incorrect by less than 4 megawatts when considering the plant's total power output range of about 75 megawatts. This is a low error rate that is highly valuable for real world operational planning and optimization. Finally, interpreting the model, we found that ambient temperature was the most influential feature, which aligns perfectly with how temperature affects the efficiency of the gas turbine component. In summary, we successfully applied the end-to-end machine learning process, correctly identifying this as a regression task, comparing two different algorithms using robust cross-validation and selecting a highly accurate model with a final test set RMSE of 3.86 megawatts. Thank you.